Hello, everyone. Welcome to today's webinar, Real-Time Analytics with SingleStore. My name is Kang. I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you're currently in a listen-only mode. You can submit questions using the Q&A function in the lower right corner of your console. We will answer your questions at the end of today's session. After the session, you will receive an email with a link to the recording. And if you wish to contact us, please email us at team@singlestore.com. So let's begin. Just a quick introduction of our speakers today. Dominic Ravita is the VP of Product Marketing at SingleStore. He has close to 30 years of experience in data infrastructure. Dominic, in his off time, is a musician and an avid soccer fan. Dale Deloy has been building applications to solve the toughest customer problems for over 30 years, and the last 5 years has been focusing on solving problems with high volumes of data ingest with low latency requirements, coupled with a massive user concurrency. Welcome, guys. You now have the floor.
Hi, everyone. Thanks for joining, and Kang, thanks for that introduction. We're really excited to talk to you today about real-time analytics. And Kang, are we sharing the screen here?
Yeah, I can see your screen.
All right, terrific. So let's cover the agenda. We'll talk through a little bit about some trends in real-time analytics, how we're seeing real-time data change in industry, and we'll talk about some requirements there as well as customer use cases. Then I'll hand it to Dale Deloy, who's joining us, to talk about SingleStore capabilities. And from an engineer's perspective and a solution architect's perspective, what are the capabilities that SingleStore provides to address these use cases? And we'll close with a demo and some Q&A. So with that, let's get started. So real-time data and cloud and the hybrid cloud are three large trends that we're seeing converge at the moment. And these stats help to provide the context to help to quantify a little bit about what we're seeing. And so these analysts have put together these surveys to understand the adoption of public cloud services for data and analytics. And when you look at the first stat there, and that 90% of that Gartner finds that in the trends in 2020, that 90% of the data and analytics innovation is going to be done in public cloud services. That helps to really highlight where a lot of the new application builds are happening and where data analytics applications with new data are being run and built. Yet at the same time, as you see that, you're seeing this next stat and this adoption of the hybrid cloud, where more on-premise workloads are being moved into a hybrid cloud environment, which makes sense when you look at the existing data estate of on-premises and data centers, corporate data centers, because a lot of these applications and data, some of them are going to stay in place where they are. And so there needs to be a way to integrate across these and to utilize data effectively. So we see this hybrid cloud trend at the same time. And with that, the last trend identified here by IDC, that by 2025, nearly 30% of all data is going to be generated in real time. So what are we talking about in terms of real time, right? It varies by the use case, but generally what you first need to support from a requirements perspective is the ability to do fast ingestion. All of these different data sources, IoT sensors, for instance, signals on a manufacturing floor, customer signals in a marketing funnel, all of these digital fingerprints or footprints are what's being ingested to try to make sense and provide context, either for an operational point of view or for better customer experience. And the first part of that is being able to ingest the data as that transaction takes place. In today's distributed environments, the ingestion itself has to be high speed and parallel and has to come from cloud native sources, but also on-premise traditional types of sources. As we see these trends of hybrid cloud and public cloud, both types of data sources are important. Secondly, once you gain access to that data, how fast is it available? Is it immediately available for analytics, and how quickly can it be processed? So this is a processing speed kind of requirement, and no matter what the use case is in terms of what real-time means for the situation, whether it's sub-second or it's correlation of data across huge amounts within a few seconds, the speed of being able to process that either through queries or some transformation is pretty important. Thirdly, how do you provide access to that data? Because again, from a user experience point of view, unless they can gain access to what's been ingested, gain access to what's been processed, transformed, queried, if the data layer can't support high concurrency, if there's some blocking there, then the user experience is no better for that. So this user experience can take form in dashboards. It can be in the form of real-time APIs fetching data. Those APIs may power mobile applications, they may power other systems, but they're expecting to have access to fast changing data. And then finally, the system has to be able to respond in a consistent manner for those different client applications and also users in a consistent way, in a reliable way. If there's a lot of variation in the response time, the query time, then it's a user experience problem. You get unnecessary tickets that you wouldn't have had, or you get customer churn because they just don't adopt your mobile app or don't use your dashboard and they feel like it's too slow. So having a reliable, consistent SLA that can be met for this real-time analytics service that you're providing is very important. So when we think about the sorts of use cases that SingleStore encounters and customers, these are a few sample use cases that are different kinds of real-time analytics scenarios by industry. And we see this in financial services and things like portfolio management and fraud analytics. And it's clear why these sort of top the list in that area, because what do you expect from your portfolio management provider, your wealth management provider? You expect instant access on your phone or your tablet to the portfolio positions and all of the other data. So you need a quickie, snappy, responsive kind of app. Internal to a financial institution is managing fraud analytics. So getting operational efficiency and closing the window of time by which you identify and act on fraud is particularly important. And we could cover other examples here, for instance, in media and streaming, where we're seeing this explosion in this COVID era of digital streaming services of all kinds, video streaming, streaming media, movies, of course, the advertising dollars that go along with those digital services. This and several more sorts of use cases where you have a direct relationship with your customer and an immediate kind of response in terms of the customer experience. If your video is pixelated, if your game is pixelated, it's a poor gaming experience or user experience, and it leads to customer churn. So just having monitoring, business monitoring on this, diagnostics to understand what the service is one of the key use cases here. And so what does SingleStore provide? SingleStore provides the unified database for fast analytics, and we deliver speed, scale, and agility for this. So when we talk about speed, we're talking about some of the elements I just described of requirements for real-time ingestion, real-time analytics, which is fast ingestion, fast query, and fast computational processing speed. But also speed of development, because SingleStore is a distributed native SQL database. It provides the familiar interaction of ANSI SQL. It's MySQL Wire Protocol compliant. So speed of development, speed of delivery of your application is part of what we mean here. Secondly, scale. With SingleStore, it scales to the needs of real-time analytics. One of the requirements that I just identified was high concurrency. So the scaling of the concurrency, getting access to that data is really important. But also when we talk about scale, we're talking about the size of the data. the different dimensions of data where you could have unstructured, structured, semi-structured, things like JSON, raw text, geospatial data, time series data. All of these are treated as first-class citizens in SingleStore, so you can join across them as it's a distributed native SQL database. And then finally, agility, being able to develop your applications on SingleStore in a way that you're familiar. If you like the pattern or a document suited or a key value type of pattern suits you, then you've got the agility and flexibility to ingest that native JSON data, for instance, ingest that native JSON directly to a native JSON column, and then you can perform analytics also in SingleStore. So you get the best of both scenarios. And so it's agile in that way. As your use cases evolve or you become better aware of what users want, you don't have to switch data stores. You can do document and relational together and have full scale analytics. But it's also agile in the sense of where you deploy it. So you can deploy in the public clouds, AWS, Azure, GCP, but across the hybrid cloud as well. So it's agile in that sense of deployment. So what is SingleStore used for? And there are really three big categories. The first is modern hyperscale applications. And when it comes to real-time or fast analytics, there are two categories of these hyperscale applications that we tend to find. First is can't wait analytics. These tend to be internal business experience focused kinds of applications. You may be monitoring supply chain visibility. You may be monitoring the diagnostics of another business process, and your internal business stakeholder can't wait on slow data, batch data. They need in-the-moment context on what's being provided. Secondly, the other categories won't wait customer experiences. This really matters for your digital product often. It's your real-time API you're exposing, or it's your SaaS application you're exposing. And so SingleStore is ideal for this as well, and we'll get into how it uniquely solves this for these types of modern hyperscale applications. A second category of use cases is predictive analytics. And so AI models are very hungry for data. If you want to operationalize AI within many business processes, which is what's been happening in a large way in the last few years, your machine learning models need quick access to large amounts of data. They need to be in the stream of the transactional flows. But if the access to that data has latency, or you're restricted by the different variety of data that can be fed to the model, then you're going to get a less than optimal result. You want to consider all the relevant data to run your model against for the best outcome. So SingleStore helps to break the data bottleneck to give you that ability for operationalizing predictive analytics. And then finally, IoT analytics. So there's, in the growth of wearables, AR, VR, IoT in the field with energy, transportation, autonomous vehicles, all of these are emitting more and more data. A lot of it is time series data. And again, you need to perform these kinds of real-time analytics on these real-time data streams. And SingleStore uniquely solves for this. So in a nutshell, SingleStore helps to break the data bottlenecks to the growth in your business. And we help our customers deliver on the moments that matter, whether they're the customer experience examples I gave in use cases or the business experience use cases. So with that, let's cover a couple of customer examples here. So True Digital is a telco in Southeast Asia, and they provide cell phone access to a couple of countries, over 30 million mobile phones. And at the beginning of this pandemic, they were looking for a way to partner with the Thai government and the health officials to take a more proactive stance in the scenario to help prevent the spread. And so for this use case, they realized that with the anonymous locations of mobile phones, they could identify, population densities across the country. And of course, the population density at any moment in time correlates to the possible spread of the virus. And so what they were looking to do in their their idea was, how could we use this continuously changing, fast changing data of locations of mobile phones to identify population density changes and the rate of changes in those. And so there's a huge amount of data to ingest. It's immediate analytics on that data, in the sense that, you know, they want to be able to take proactive action. And so having this, you know, on a batch basis, an hourly report or half an hour report, you know, they want to be able to identify as soon as possible to get at this scenario. So let's try to quantify this a little bit in terms of speed, scale, and agility. So speed, they built a geospatial solution on SingleStore in just over 2 weeks. So the speed to development was super fast. And part of what they attribute that to is the fact that SingleStore has a familiar, you know, MySQL wire protocol support. It's some familiar ANSI SQL. And so you have the constructs of what you need to quickly get started. In terms of scale, it met the needs in terms of the ingestion of 500,000 events per second. And so these events are the location pings, the anonymous pings of those cell phones. It's just basically a phone with a coordinates for and other data, but you know, hundreds of thousands of events per second from more than 30 million phones. And so what you're seeing here on the right is a view of the real-time dashboard built on top of this data, where they're calculating real-time analytic metrics. And some of you see in the pop-up window in the middle, the real-time density. They built triggers against those particular changes in the number of entrants or exiters. And because SingleStore supports geospatial data as a first-class citizen, a lot of the geofencing functionality could be built right into this application. So it allows the user to just draw a geofenced map and an arbitrary geofenced area to calculate this, as well as having pre-made metrics in addition. So another example, so I'll give that as sort of the external example to help health officials. Here's an internal example of a major US bank customer who used SingleStore to break the data bottleneck when it comes to fraud analytics. Of course, being able to shorten that window of time of detection can mean a lot. And there's a large amount of data that has to be considered, and the data or features that are predictors of these things, of what possible fraud is, it's a continuous refinement of that. So this, you know, kind of real-time analytics is using a machine learning model. So we'd call this a predictive analytics scenario. And we were able to reduce this to a very small window of time to accurately score these potential fraud transactions. So what do these use cases have in common for real-time analytics? All of them involve this idea of quickly identifying the business event of interest. This also is the context needed. And so there's a point in time, which is what the purple star is showing here, when the actual event happens in the real world. Then there's some time before the data can be captured, some other time T2 until the data is analyzed, and finally some action taken. So with real-time analytics, you're looking to reduce each of these time periods, and SingleStore helps you do that for cloud and hybrid data at scale for any data in any environment. So with that, let's cover a few of the capabilities of SingleStore, and for that, I'll hand it to my colleague, Dale Deloy.
Very good, thanks, Dominic. And talk about SingleStore. First of all, SingleStore in one slide. What is the SingleStore database? It is basically a relational database built out on principles like Hadoop, where with MemSQL, you simply add nodes to scale this architecture. But it is built as a relational database from the ground up. So it is an ANSI SQL database with full ACID features. It also is a lock-free architecture. What we mean by the lock-free architecture is that our readers don't block our writers, and our writers don't block our readers. Now, of course, since we're ACID compliant, we have the full durability structures, but a writer will, of course, have to block another writer in order to provide the proper access and the proper consistency for that single row. Another key component of SingleStore is not only do we handle standard relational architectural and data model structures, but also JSON, a full document model JSON structure, as well as a geospatial architecture, right? So the ability to do geospatial analytics, as Dominic talked about earlier with True Digital and others, leveraging us for geospatial. Additionally, there is full text search built into the architecture as well. So you have the ability to handle all different types of data, both your relational structured, your JSON document semi-structured, as well as unstructured data in the database. As we go off to the right-hand side here, we'll talk about transactional and analytical stores. SingleStore has multiple types of data stores built within it. And it has an in-memory row store structure, which is fully transactional, built around basically moving data into an in-memory component. It also has a full column store built in, with the ability to actually stream data directly into either and or the row store structure and the column store structure. And that's something truly unique about SingleStore, is that the ability to stream data directly into what is defined as a column store is something that very few or no other technologies can really handle. Now, if you go to the bottom left here, we'll look at the low-cost structure. SingleStore is a shared nothing, massively parallel database. That allows us to basically simply scale out with adding commodity hardware to the architecture. Similar to Hadoop, as Hadoop is made up of name nodes and data nodes, SingleStore is made up of aggregated nodes and leaf nodes. To simply add data, to add concurrency, to add resources, you simply add nodes, rebalance, and in an online fashion, your cluster is larger and able to handle more data, more rows. And also, we're deployed anywhere. The ability to deploy in an on-premise mode, but also in any of the major clouds. And also, not just to deploy in one, but to replicate and move back and forth between them, to really protect anyone's investment from any single cloud, so that you can simply move data, replicate from, let's say, an on-premise environment into a cloud environment, provide that cloud environment for your disaster recovery, or vice versa, go from an Azure environment to a on-prem, or an Azure environment to an AWS environment, or AWS to Google. All of those capabilities built into the architecture. SingleStore is a unified database for fast analytics. And this is really the Gartner HTAP term, hybrid transactional analytical processing. And SingleStore is built to be just that database, where we basically are able to take operational workloads, basically high-speed data lookups, right? Both from an ingest perspective, as well as a very fast query lookup perspective, as we built the query engine directly into the chipset. So as you look at a chip in the AVX2 instruction set and chips, we basically have built the query engine directly in there. So we provide very fast data lookups in a compiled structure to pull data out at very low latency and high concurrency types of structures, as well as we provide full analytical structures on top. So having the ability to provide fast queries and large data sizes against our column store structure now, instead of maybe our row store structure, or again, combining the two. And that's a key component of what SingleStore has done. And that's why the name basically changed from MemSQL to SingleStore. We've combined the ability to basically house and leverage data in a transactional workload and store it like data that needs to be accessed as an analytical workload together all in one database and in one table structure, right? And we do that all behind the scenes. So the developer or the end user does not see what happens behind with the data. So we'll talk a little bit about what does happen with the data. What happens with our SingleStore, right, type of an architecture is that we basically ingest data into the in-memory row store, right? And then just data into that in-memory row store is really good for OLT types of transactions, insert, updates, and deletes, single inserts, updates, and deletes, right? And it allows us to handle things massively concurrently, but we don't have to do everything in large batches. And when we do queries against this type of a structure, we're usually getting millisecond response times. We have many different customers where their SLA is 20 milliseconds or less. Right? When we look at many of our, I'd say, customer-facing applications, we're actually delivering 10 millisecond consistent application response times at concurrency that's over 6,000 transactions per second at one banking customer we're working with. Now, what we've done is that we've combined our in-memory row store with our column store. And that column store is really all about doing analytical queries, but together we're able to do both the ingest and the analytical, right, all at the same time. And we'll show that in the demonstration here in a little bit. But what we've done is basically by combining those two together, we've created this universal storage where we're able to do very high speed data ingest, right, in a very simplified architecture, right, driving down our costs so we don't demand data to be in memory like you would have with many of the NoSQL, like a Redis tool set. Right? Instead, we're going to basically take that data, ingest it into memory, be memory first. When we hit a threshold, we're going to automatically spin that data into the column store and have then compressed column store structures with very fast data access still. So that delivers very low cost in our infrastructure, as well as the ability to query that at high speeds for very low latency. So what is SingleStore, the database of now? Basically, ultra-fast data ingestion, the ability to run stream data from all different types of environments. Super low latency of queries to deliver the best customer experience, whether that's an internal or an external customer, and to do that at very high concurrency. We have customers where they're ingesting over 12 million transactions per second into the database, and other customers that are querying and have over 60,000 concurrent queries per second running in their architecture. A little bit about the real-time analytics stack, the things that we interoperate with, the sources that we pull from. So your standard object stores that you're going to have out in the cloud, an S3, an Azure Blob type of object stores we pull directly from. Also, we have direct Hadoop connectors. So we have our pipelines that are basically going to be pointing at any of these scenarios at S3, Azure, or Hadoop. Simply point our pipelines at those, and we'll basically leverage our pipeline structures like a change data capture environment where we're polling that source to understand what has changed, what's new, right? And also with Kafka. Our most popular interaction is with Kafka and the ability to stream data from Kafka, right, into a SingleStore database at very low latencies and very high speeds. As we're streaming that data in, we have the ability to transform that data on the fly into our environment. And we either can transform that data or just push it directly into a stored procedure, where not only can we write it into a table, but we can also trigger additional events, right? We can look up more detailed structures and trigger additional events so we can bring data in from all these different sources, right? But then trigger events and write that back out to Kafka. So not only can we read from Kafka at high speeds, but we can write to Kafka and trigger additional events, and then have other applications and other processes pick those events up to process further. And the bottom line is we're basically ingesting our data into the SingleStore database, which allows you to execute everything in parallel. So now that I've got this data streamed into my analytics stack, it's in the SingleStore database, and I can access it with very high speed and high concurrency query. So now I'll go ahead and do a demo. And we'll bring up our SingleStore Studio. Here I have a simple environment. It has 4 leaf nodes and a master aggregator just for demonstration purposes. Just a standard demo environment. And we're going to basically go through and talk about and show some streaming capabilities where we'll bring in a couple of pipelines and we'll run some queries against those pipelines. Here I've got the ability to do different pipelines, and I'm showing the detail here, how to execute and basically load pipelines. It's very simple. So the first one is basically loading data from Kafka. You can see in the base structure, I've got load Kafka against this particular topic. And this happens to be bringing in refinery data topic information. It's basically setting up a batch interval. Now this can be set much lower, right? This happens to be set at 2.5 seconds. So every 2.5 seconds, we're going to start ingesting another Kafka batch. We can set that much lower to be, every 100 milliseconds, we can start another batch and keep the data streaming into the environment. Here, we're just going to load that data into a table with this field called historian table, right? And again, it's standard fields and field terminations where this happens to be just CSV data we're going to stream into this or from this Kafka environment. I also have the ability to do files, right? To see pipelines, right, as S3. So I'm basically going to be able to look at an S3 bucket, right, and look at that S3 bucket at any point in time, pull in data from that S3 bucket directly into the SingleStore database. Here I have, you can see that I'm pulling data into our table, but I also have a set of transformations. So not only can I kind of do transformations at a kind of an exit perspective and maybe even in a transform call, like a TensorFlow or something like that to score my data on the fly, but I can also do transformations of the data row by row as it's coming in to, let's say, just modify, in this case, a date structure. Right now, I've got pipelines that are up and running. We'll go ahead and show pipelines. Right, and I've got a pipeline here, a load test batch ingestion pipeline that I'll go ahead and show what's happening with that. I'm going to go ahead and just show our summary, execute the summary, and we'll show what's basically happened with this particular load. So this particular load, normally when we're talking about batch, you're not normally talking about this level of execution. Here we loaded in a very large batch of, this happens to be 33 million rows in this batch, and we loaded that batch in 8 seconds. That gave us a standard ingestion rate of almost 4 million transactions per second. So 3,799,494 rows per second ingested into the database. And as we're ingesting that data, we can execute queries. So we have that data ingestion happening. I can basically look at my tables that we're ingesting into and see I've got 31 billion rows coming into that table at this point in time. Now I can run while that data is being ingested, I can run a full table scan on 31 billion rows. Right? Now that full table scan, I'm forcing a full table scan. So in 4 seconds, I did a full table scan on 31 billion rows, right? Now that's analytics for you, right? Doing 31 billion rows in this type of a time frame. I also have the ability to run Queries that are going to be, rather than forcing full table scans, they can be periodic queries to execute my data here. So in 444 milliseconds, I got a result of that query execution. Ability to do more complex queries using common table expressions. The ability to basically do time bucketing and execute queries against time buckets. And then finally, I'll just end this demo with a little bit about JSON. With the ability to handle JSON, you've got a complex JSON doc that has basically 10 different arrays built into this JSON doc. What we've done to allow you to basically stream through JSON and be able to query JSON is we allow you to take the array and pull that into a table structure. So here we're pulling that journal array into a table structure, and then we're querying that table structure. So here is the full query where we're basically going to pull out the creation date out of this massive set of arrays of JSON and execute that. And now what we can do is basically flatten out any JSON. So now I can basically flatten out this JSON doc that has 10 different arrays in it, make it look like it's just a table. So now I can put BI type of tools up against that data. So I'll do now, go back to my presenter role and go to Q&A.
Thank you so much, Dale. So Dale, would you mind moving to the next slide?
Yep.
Sounds great. All right, so we'll begin the Q&A portion. Just as a reminder, you can submit questions continuously. So, all right, first question. Is it more efficient to ingest data via pipeline than to push it through a JDBC API? By how much and why?
Absolutely. And I'll talk about, it's all about parallelism. Right? When you're doing JDBC or ODBC, your parallelism is limited, and you're also going into a structure that is into our aggregator, so it'll have fewer threads to load. What we do is, if you're going to be leveraging our pipelines, we're going to match the parallelism of the source to the parallelism of the database. So if you have 32 partitions in your Kafka environment, we're going to match that with 32 threads to ingest in parallel into our partitions directly. So it's a very high-speed data ingest, massively parallel to match the parallelization of the source. Makes it much faster than your ODBC or JDBC structures, and it gets rid of the ODBC and JDBC overhead that you have of basically passing data back and forth.
How do you achieve high ingest rates in the context of immediate consistency between widely geographically distributed nodes?
Yes. So we ingest, but we are what I would call synchronous and consistent within a data center. Right? So we are not, we are asynchronously replicating to the widely distributed. So we are immediately consistent to 2 copies of the data within a single data center, and then eventually consistent or asynchronously replicating to the secondary data centers or geographically distributed data centers.
Great. Do we plan to bring in RabbitMQ pipeline anytime soon?
I believe they are in the roadmap. Dominic, any comment on that one? I don't.
There are a lot of Java-based message queuing systems. So RabbitMQ is one of those with a Java API supporting the JMS sort of standard. What we see primarily are cloud native sources, but I'd say there's a large variety of these sort of message queuing systems that in different environments. So yeah, I would say probably the immediate way to access that today would be to have a Java consumer from your queue and then write that as an use the JDBC API, for instance, to write that, or use a bridge from MQ into something we do have a a streaming ingestion in with something like Kafka, for instance.
Thank you. Does the streaming ingest handle duplicate events?
Yes. So there is on duplicate key capabilities within your streaming. So I can do things like on duplicate key update, or I can do on duplicate key ignore. But I can basically handle duplicates, identify them based on unique keys, and then process them according to the policy you have on handling duplicates.
Great. What modeling functions are within SingleStore? Ingesting SingleStore data into Python and then performing data mining tasks seems too slow.
With mining functions, it's basically analytical SQL, right? As well as if you've indexed your data, you can have a full text search capability. So any type of SQL analytics to mine your data is available to you.
Yeah, and I would add to that if you're, as Dale said, you can use the robustness of the SQL language to do a level of data transformation. You can use a series of SQL statements to basically create sort of a data engineering or data preparation pipeline just within the data that you've loaded into SingleStore. When you want to run a model, a machine learning model, you can do that at ingestion time through SingleStore pipelines. It allows you to embed, the question is Python, so you can embed a Python executable in that ingestion stream to basically do things like score the data upon ingest, and the output might be a calculated column in SingleStore with a scoring for that data. Another scenario where you may embed a machine learning model is through a user-defined function, a UDF, in SingleStore. And of course, you can do, use SingleStore as a refinement step in your, data engineering pipeline, for instance, and use also select into an outbound Kafka stream. So in that way, you can see you can use it as a very efficient compute and storage, distributed compute and storage cluster, and then treat the SingleStore as a filter and an enrichment step, and then write out that refined data into a Kafka stream for other processes.
Thank you. Given eventual consistency between data centers, how do you handle conflict detection and resolution between data centers?
Well, let me answer that. I think with any kind of application that spans geography around the world, it's very specific to the application logic as to what the scenario is. So we found that you choose a system of record in a geographic home, you provide the synchronous write within that availability zone, as we do, and then you either read and write from that, or you gather that data on an asynchronous basis to other nodes. That is the simplest way to get global scale across a network of clusters, because each application has its own logic about who wins in those situations, and it's so application specific. If you're looking for a general purpose solution, we find that this model works. It's simpler to maintain, manage, and more deterministic when it comes to the state of data.
Do you have live materialized view on the roadmap?
Yes, so there are materialized views in our 8.0 release. Today we're at 7.3, so we're probably a little over a year away.
What index structure exists? Are they distributed across data centers? Are unique constraints enforced?
So what index structure is used? Well, there are multiples. There's a in-memory skip list index that indexes the data as it's coming into the row store. There's a hash index that is leveraged within our column store. So our column store has both a column store index structure as well as a hash index structure. And in that hash index structure, we identify or maintain unique keys. And then
Right.
I think the last part was around distributed. So basically we're providing a consistent single data center and then distributing it asynchronously. So the keys will basically be consistent across the model in all data centers.
That's great. Thank you so much, Dale and Dominic. So I want to thank everyone for attending and asking all the great questions. This is actually all the time that we have today, but just as a reminder, we'll send you an email with today's recording. We'll also like to invite you to our upcoming events and webinars. So you see it here on the screen. The first one is actually tomorrow. Join us for a developer ANA. This one is with our developer evangelist, Rob Richardson, specifically around the topic of schema migration and data syncing. And then for Thursday this week, we have another webinar, but this one will show you how SingleStore can help power faster dashboards. And then next Tuesday, exactly a week from today, we'll talk to Scott Cuffer, the co-founder of Nucleus Security, about the cybersecurity use case that will help support. Last but not least, we'll invite you to start a free trial today at singlestore.com or reach out to us with any questions at team@singlestore.com. So thank you so very much, and we'll hope to see you at the next webinar.
Thanks, everyone.